The nature of matter has puzzled humanity since the antiquity. As far back as the ancient Greece, some have wondered, is it possible to split a rock into two again and again, forever? Well, according to Greek philosopher Democritus, no. At some point, he postulated, you'd come across a piece of rock you would not be able to break apart any further. Democritus called it atomon, the Greek word for indivisible. Yet, the atoms remained nothing more than philosophy for millennia, until 18th century discoveries like the law of definite proportions led an English chemist, John Dalton, to propose a following atomic theory. All matter is composed of extremely small particles called atoms. All atoms of a given element are identical, but those of different elements, different mass, size, and other properties. Atoms can neither be created nor destroyed, and a given compound always has the same proportions of atoms. This, however, was not the full picture. In 1897, J.J. Thomson used a cathode ray tube to observe a stream of particles. By measuring how these rays behaved in magnetic and electric fields, Thomson concluded that the rays consisted of negatively charged particles that were later named electrons. His findings were further refined by Robert Millikan, who in 1909 accurately measured a single electron's charge with his oil drop experiment. Despite these discoveries, however, the relative distribution of charge within the atom was still unknown. The scientists assumed the atom was shaped like a plum pudding, with the electrons suspended in a cloud of positive charge. Hence the name, the plum pudding model. In 1899, Ernest Rutherford attempted to test that model by putting a gold foil target in front of a beam of alpha particles produced by a radioactive source. To his surprise, while most particles went through the foil unimpeded, some had bounced right back. Rutherford concluded that the positive charge in the atom must be confined to an extremely dense nucleus composed of chunks called protons. However, the numbers didn't quite match up with the reality. You see, since helium nucleus has twice the charge of the hydrogen nucleus, the theory predicted it to have twice the mass. Yet the helium atom was 4 times as heavy as the hydrogen. To compensate for the discrepancy, a new particle was proposed called Neutron, with the same mass as proton, but no charge. In 1932, the neutron was confirmed experimentally by Chadwick. Our understanding of the atom continued to improve throughout the 20th century, alongside further advances in quantum mechanics. However, that stuff is really beyond the scope of this video. Thanks for watching.